Welcome to Brain Vision.
In this question, we have a sample that we put a certain amount of heat inside and we recorded the temperature as a function of time, and the plot is here. And the first point, we want to know what is the latent heat of fusion of the solid. The fusion is happening in this part here where the temperature is not rising. The interval of time is between 1 and 2.5. So the heat Q in the plot we can read directly as being the rate of heat that we put inside times this interval here that I'll call TL. So let's put the L here, HTL. And at the same time, this is equal to the mass times the latent heat of fusion of this solid. We know everything in the left side. We don't know LF. We can write for LF. So LF is equal to the heat input, the difference in time that we stay here, divided by the mass. Let's put values here. So 10 kilojoules times 1.5 divided by 0.5. This is equal to 3 times 10 to the 4th joules per kilogram. So this is the first part. Now, what are the specific heats of the liquid and solid state? So here in the left we have the solid state, else, and here we have the liquid state. And this interval here I'll call TS. And here I'll call, I have to have a longer letter, so I'll call T final. This interval between TL and 4. So let's calculate first for the liquid. So for the liquid, we have Q is equal to MC, the difference in temperature. So see liquid, and this same time you just need to see in the plot what the value is. So this is from here to here. So this is T of liquid. We need to solve for CI, so CI CL is equal to H T liquid divided by M difference in temperature. And we can put values here, so 10 kilojoules. So we can 10 times the time, the final time is 4 minutes minus 2.5 minutes. The mass is 0.5, and delta T is 40 minus 10. This gives us 1000 joules per kilogram Kelvin. So for the second part, for the solid, is the same thing, but it's in this part here. So let's open a new one and do this. The C of the solid will be H, the time of the solid, and M delta T. Delta T is difference in temperature. So this is 10 times the time it takes in this phase. Let's look again, is 1 minute. So 1 minus 0 divided by the mass is 0.5, and the difference in temperature, it goes from -5 to 10. And plug in the values. This is 1300 joules by kilogram Kelvin. So we obtain both specific heats of the solid and the liquid state and the latent heat fusion